A new add-in has been created for dealing with complex cavity hole forms using a multiple stage process. In the first stage, the user analyzes a set of standard cavities from a template block or sample part. This initial teaching stage establishes the standard forms, with the data being stored in a tabulated form for later use. Once this table of data has been established, the stored data is then applied to parts to quickly create features and machine with the appropriate tooling and strategies. This can be applied to examples such as standard hydraulic connection cavities from SAE, Sun, and so on. In this example, you can see we've got our standard block in front of us with a number of standard cavity forms from Sun. What we want to do is we want to teach the system the parameters regarding these holes and then apply these teachings to our part, which is the second example. So first let's load the add-in. We can do this from the folder in the graphics screen. In this case, you'll see we have our port cavity add-in, which is what we want to load. I'm going to copy this location, and then under my options, add-ins, I'm going to browse for that add-in. Once I've loaded that in, I can choose OK, and you'll notice I get a new toolbar with 3 icons on it. The arrow icon allows us to swap between ports only mode from our query mode. We have the key icon, which allows us to configure the cavity table, and then we have the option for editing the definitions. First thing I'm going to select is the configure button, and you'll notice in this case we have several parameters that we can control. We can choose whether we're creating the ports, whether we're investigating the part with the query only mode, or disabling the functions. We can also choose any of our standard tables that we've got saved, or you can add your own custom tables if you wish to do so. In this case, I'm going to create a new table, and I'll call this one test, and say OK. If we go back to our configuration, you'll now see we have a new table that we can start populating with values. I'm going to choose the query only mode and start investigating my part. To do this, we simply go into our new feature wizard, we choose hole, extract with feature recognition, choose next, next again. We're going to uncheck the pattern option, and if I rotate round, you can see we've got quite simple hole forms down the component. I'm going to select all and say finish. Note if I hide the front of the part, you can see the holes themselves are a lot more complex, but we've got some simple forms that allow us to extract the dimension information. If we go to the part view, we can see we've got the dimension checks have appeared in the list. Each one of these is a different size. If I double click, you'll notice that the dimensions have been split into different levels. All of these can be added to my process. Depending on whether I have them checked or not, you'll see those will be added into the table. Here, for example, if I uncheck the dimension check 5 and go into my port cavity definition, you'll note that we have a placeholder which is just an empty profile, but I can choose the load IFR, and this will bring in each one of those that I have selected. In this case, you can see we've now got 4 definitions out of the 5 that I had selected here. Each one of these can then be edited. I can choose and refresh the window and then rename. In this case, you can see the names are already given for each one of these locations. The first one is a T-8A, and you'll see that updates in my definition list. You can repeat this process by selecting the second one, refreshing the screen, and then renaming these. So let's call this one T-9A, And the third one, again we can rename T-10A. If I have any dimension checks that I don't want to include, I can go ahead and delete those from the list. I'll only be left with the ones that I have decided to keep. Each one of these can then be checked in terms of its dimensions by going to the Edit IFR, and you'll see you get each of the different levels for each of the different sizes. As well as that, I can also go and change the process. So for example, I might want to pilot drill, form drill, ream and thread, and in each case I can enter the parameters. For example, I might want a depth of 20 millimeters and a diameter of 8 for my pilot drill. Once I've chosen OK, those will be stored, and when I go back to my T10A, you'll notice that we get an update of the parameters when we make it active. So let's have a look at an example where we can apply this learned table data to. In the second part of this demonstration, we're going to work on this hydraulic selector valve. In this case, you can notice there are a number of cavities already pre-created. What we want to do is go ahead and recognize these and machine them. If we look at the part view list, we can see we've already got a number of features that have been pre-generated, and you'll notice some machining around this casting form. That's our component so far. Let's go ahead and recognize the cavities using one of our tables. In this case, I can go to my configure mode, and I've got the option to do ports, query or disable as before. In this case, I'm going to go to my ports only mode. I'm going to use the Sun standard table that I've got already established. Let's say OK. We're now in port mode. If I have any concern, I can always switch into port mode by selecting the arrow icon. I can now go in and choose my hole, extract with feature recognition, cycle all the way through, and you'll notice it identified the two holes. In this case, we don't extract the form in terms of the graphic, it just simply gives me an indication as to where that port location is. I'm going to choose to select all and finish. Replay my 3D simulation, and you'll see I get my complex cavity form like so.